Hey guys, welcome to the second part of the video for our interference. So this time we're going to be looking at everything in points number 2. So that's coherent sources of light and Young's double slit experiment. So coherent source of light involves two things. A light that is monochromatic and light that is in phase across any lateral cross section. So here we already have a diagram of an example of light that is not in phase. So if we took this cross section, we have everything from an equilibrium position down here to a negative amplitude and a positive amplitude. So this is out of phase. If we look at something that is in phase with each other, we're looking at something that is, well, this is exactly in phase with each other like this, such that if we take a cross section, let's say that, then all of these are the negative maxima, all of that is the positive maxima, and everything through there is at equilibrium position. So that's what we mean by something that is in phase with each other. Okay, so all the waves are exactly in phase with each other. The other thing is that it is monochromatic. So monochromatic really just means that it is of a single color. I invite you guys to think a little bit about the visible light spectrum, where we have red light. Okay, so actually each light color, each shade of color actually has a different wavelength, and sometimes you may not be given the wavelength directly. You may have to find it using c equals to f lambda. So you might be given the frequency of the light, you might be given the wavelength, and if you're working with electromagnetic waves, remember that the speed of light in a vacuum or air is always 3 times 10 to the power of 8. So there's a hidden assumption there that they might throw it at you. Okay, with Young's double slit experiment, there are 4 variables. So we have S, we have lambda, we have big D, and little d. So first off, lambda is the wavelength of light. We just briefly talked about that over here. Nothing too special, just tells you, sometimes it might actually just throw a curveball at you. It might say you have, red light. And then you're sort of expected to know, okay, red light is 400 nanometers. And then, that obviously makes your life a lot easier because you've already memorized the wavelength of red light. D is the separation of the slit. So if there's a slit with 2 slots, D is that separation distance between the 2 point sources. Big D is the distance between the slit and the screen. And S is the separation between the bright fringes. It also happens to be the same separation between the dark fringes as well. So if we look at a diagram down here, we can kind of see that. So if this part in the middle is the central, which means the other side will sort of mimic that as well. So if that's the central, then what we're really saying here is that the distance between the brightest parts, so everything in red here is the brightest stuff, the bright fringes, we call it, is the same distance as the dark fringes. Okay, and so both of those separations are the same, and because of that, we only have one single formula. Okay, same as the separation is the same, have the same separation as the bright fringes. And that's Young's double slit experiment of how, using a double slit, we can create an interference pattern in terms of intensity levels, something like what you see here. And this formula describes how it works. That's about it. And of course, you might be expected to describe certain things. So, what happens if we decrease the size of the slit? How does that affect the separation of the fringes? So, if we decrease that, then that should increase the separation or the distance between the fringes. So let me see here. If we have decreased the D, we increase the separation, which means we might have a big maxima like this. The next one here might be like that. Okay, so this is a oh, it's not working anymore. This is a smaller D, and this is a larger D. Okay, so you might be expected to understand relationships like that. Okay, I'll go over the examples in the third follow-up video.